Hi, this is Gray Lovelace with Technically Speaking with Source Allies. Today we are going to be learning about a specific way to interact with generative AI called a Retrieval Augmented Generation. So if you have ever been interacting with AI like ChatGPT and you're like, man, I really wish that I could ask it about things it doesn't know already, this is exactly what you want to do. You've heard people talk about training models in the past. This is kind of the step before training models. We don't really want a model to behave any differently. Instead, what we want to do is just make that model context aware of some other information that we want it to know before we ask it our question. In this particular case, we're going to give it either website data or PDF data, and then we're just going to be able to basically chat with that data, which is a really cool concept. So let's dig into some different ways that you can just interact with models at all. If you look down here, we have the Gray Lovelace RAG chat GitHub repo that should be available for everybody. And you can see that this is a small proof of concept going over exactly what I said before, but what I really want to dig into this specific diagram right here, which is different generative AI data patterns you can use and how complex they are to implement. So we actually have another video that I posted before about translating and then adding more information to recorded audio notes, which is a great one. It's definitely linked in the description. You should go check it out as well. That is a really great example of contextual prompt engineering that you can leverage without the model needing to really know any specific data besides what you're feeding it in at that particular point. This is the next step called Retrieval Augmented Generation, or RAG. And RAG is great because you can scale up a giant data source and you can take different data sources and embed them to where they have kind of dimensional numbers that relate to what the content of that data looks like. And then you can compare your question to those stored embeddings or vectors or indexes and get out all of the pieces of content you've already embedded that are similar to your question or have data that's related. Feed those into your large language model before you ask your question, and then it will use those as its sources of information. So this is really, really great, like I said, if you have a large data source, or if maybe you're an enterprise, you have a rapidly changing data source. Training a model takes time. RAG doesn't really take much time at all. So before we dive into all of the technical specs of like how are we doing this, let's maybe go ahead and see what it looks like. So we'll pop down here. Here's a good example. What we have is some already loaded data sources, nothing on this GIF. You see that we've typed in a website that we want it to index data from. It is going to index that data, which does take a couple of seconds. That is running it through a model. You'll see it's loaded now. Info is loaded. Then we can come down here and we ask a question, and it tells us exactly what's going on. So in this case, where is Source Allies located? It's located in Urbandale at that address. So that is what we're going to get out of this. We're going to have a web UI that we're interacting with where we can dynamically load any website's data that we want to, as long as it has plain text we can consume. And then we can ask questions about those sources. And the nice thing is you can load as many different data sources as you want in here, as long as you have space on your computer. We're storing all of those embeddings locally, and then we're just retrieving them and then feeding them into our OpenAI chat service before we actually ask the question. Okay, so how does it work? We have a few different things going on here. First things first, you need a source of data. Source of data in this case usually is some kind of populated wiki, or it's some kind of like database data set, or if you're working with Databricks or Snowflake or something, you can have a pre-set data set there you can kind of feed in. In our case, we're asking the user to provide that data. It's going to be going out to either websites, or it's going to be going to some kind of directory you have on your computer to like index contents of PDF files, things along those lines. We need a model to generate our embeddings. This can take a few different forms. You can download an open source model to do that. I've done that before as well. In this particular case, I'm just going to leverage the OpenAI embedding API. So we will take our documents that are generated from our sources of data, send them out. It will give us back embeddings, and then we will kind of pair those embeddings and that embedding model with our vector database. Speaking of our vector database, you need a place to actually store your embeddings. Lots of different options here. I use Postgre a lot, and I know how to containerize Postgre using Docker quite a bit. So I just decided to go with that. I have Postgre running in a container, and I apply the PG vector extension to it, which is extremely simple. I'll show you how to do that. And then you can use that to store all of your vectors. And then also when you have your questions, it will cross-reference that question with all of your stored embeddings to figure out what pieces of context are important for this specific question. Lastly, you need a large language model to actually accept your question, accept your context, and generate an answer for you. In this case, we are also using OpenAI's chat API. So we are going to feed in that context that we've generated from all of our previous sources here. And then we are going to feed in our question, and it will give us back the answer just like we saw in the example above. Last thing here, very optional, a UI. I just thought I'd make it pretty this time. We can do all of this through the command line, but in this case, we are using the Streamlit library, which is a pretty popular, very, very lightweight web UI builder for Python. And I think we have like 70 lines of code that are popping out our whole UI for us. Last thing here, if you don't know what LangChain is I believe it has a JavaScript and a Python library that you can use to do exactly what it says, chain together a bunch of these different pieces that we've talked about when you are interacting with large language models, or really models of any kind. It has a lot of really good things to pull in different models from Hugging Face, and in our case, we are using it to marry up our OpenAI embedding API with our Postgre database, and also use our OpenAI LLM, and we create what's literally called an LLM chain out of all of these things, and it handles the context and the actual question asking before it gives us back the answer and any sources that are related. Let's look at the code. So down here, I have that exact same repo pulled down in VS Code. And let's just take a look at some of those different pieces that we said we are talking about here. First things first, we talked about our vector store that we want to set up. I'm going to start with our Docker Compose here. If you're not super familiar with Docker Compose, that's okay. I have a specific PG vector image that I'm bringing down instead of the stock Postgre image. We want it to always restart. We have just a user and a password of Postgre, which will also generate a default database of Postgre inside, port 5432 like normal. Two things to call out on the volumes here. One is that our /Postgre data inside of our repository will represent any data that we want to persist between runs. So you can index as many sources as you want, turn off your entire computer, boot it back up, run this container again, and all of your embedded data will still be there. You won't need to re-index everything if you don't want to. Right here, what we have is a very, very simple init script that is in our SQL directory here. That will just say create the extension vector. If for some reason our vector extension isn't already turned on, this will turn it on for us and we will be able to use that vector data type. All right, for this case, we are going to start up our Docker Compose here, and you should see that this SQL will run and we will create our Postgre data. That file was there before, but we deleted it off screen for you. And so you can see here, Docker Compose up. And then we are just, let's not run it detached. Let's just watch the whole thing go. All right, so you can see it's already up and it's ready to accept connections. We've created this Postgre data that's going to hold our data for us, which is great. And you can see it's running on 5432, which is also perfect. So let's go ahead and make a new terminal here. All right. Perfect. So we should be good to go there. And now that Postgre is up and running, we should be able to interact with it inside of our code. So let's go look at that vector store code that we have here. One thing that we need to do before any of this starts is if you are leveraging the OpenAI API, you need to make sure to grab an API token for that and stick it inside of a .env file. That is where it's expecting it to be, and it is expecting it to be named OpenAI API token with underscores in there. That is what I have there. I'm not going to click it there so you don't grab my token and charge me lots of money. But this right here, we'll just go ahead and load that into our environment for us. And then we have a couple of different things that are interacting with our database. The first one is going to be using a Python library to just connect to our database normally. So this is one connection to our database, and then we're going to make another one that is more specifically for the vector embeddings and that we're going to add into our lang chain. There might be a different way to do this, but I wanted to be able to query it normally as well to get things like what sources have we already embedded, and that was harder to do inside LangChain. So first one, this is our normal database connection. Second one, this is our PG vector connection, and PG vector is imported from our LangChain vector stores here. You can see it's connecting the exact same way, local 5432, and using Postgre for the database user and password because it's all containerized running locally. That's totally fine. We create a collection name, which in this case, data embeddings, website data embeddings. It just needs a name of some kind. We print out that we're creating the vector store, and then here's the part that's really important. One, we are creating a embedding model of some kind. This is another thing that came out of LangChain that is extremely easy. So you have OpenAI embeddings. You just do that as long as you have your OpenAI token in your environment, you're good to go. It's going to do that for you. And then here you have your vector store. So we created our PG vector connection string. We just feed that in along with our connection string we made and our embedding model. And now this store is available for us to both store things with and retrieve things from, and it will automatically pass through that embedding layer both ways for us. This is now available for us to do things with in all of our other files. Next thing, we want to take a look at different ways that we can embed things. So we have a function that we've created to embed URLs. In this case, we have an unstructured URL loader. There are lots of better ways we could take website data and embed it into our stuff, but for this proof of concept, it's very simple. We're just going out to a URL. We are grabbing the text data that's available there, retrieving that, ripping out any of the HTML or anything along those lines, and we're just sticking it in the database that way. So you won't be able to get as much data as you would with like a web crawler or something that converted the HTML to like Markdown for you. But this is light enough for our purposes right now. Once we have our loader, we're going to load everything, possibly print out the data that was given to us. We're going to split that up so it has it keeps context between each of our things. I won't dig into that too much. And then we are going to add those documents to our vector store that we imported from that vector store that we just talked about now. So this is fairly straightforward. Then we talk about our LLM itself, and this is also extremely straightforward. We load our .environment because we need that OpenAPI key again. Our LLM is just OpenAI. We give it a temperature of 0.1, so it's not super super liberal with how it answers different questions. And then we create our LLM chain, which is specifically one that is question and answer with sources that we want to provide, which is what you would use for a RAG solution. You do it from our LLM and you give it a retriever. So we take our vector store that we talked about before and it has a retriever mode that we pass in. Now our LLM chain is completely ready to use. So let's go ahead and look at some command line things that we can do to see what's going on here. First things first, we have this ask. So I'm going to ask something. There's an award at Source Allies called the Black Belt Award. And we want to know who were the people that won that this year. So if I run this, we should see all of our sources that we have indexed, which currently is none. And then we should be able to see it ask that question and most likely not going to know because that's not something that the OpenAI model would know right now. So if I run poetry, run Python tests and ask, you can see we have no current sources, like I said. Here's our question we asked, and the answer is, I don't know, which is completely accurate. So now, let's go ahead and embed some of that data that we talked about. So I have this other script here called embed URLs. We have a lot of different URLs that we have set up, all from the Source Allies website. The main ones that we care about are just kind of these right here. I believe About Us is the one that might have who won the Black Belt Awards this year. And then we have, we just want to embed URL for all of those different URLs that we set. This might take a couple of seconds, but it should be pretty quick. And then we can use that data from now on unless we decide to get rid of it. So now that all of these have loaded, you can see some of the different document contents that have been brought in, as well as how many documents came out of it, document being an actual item inside LangChain at this point. So this one gave us 2, this one gave us 15, and so on. So all this stuff should be embedded now. And then what we can do is we can go ask our question again. But before we do that, I want to really hammer in the part where we are actually querying our embeddings based on what we're asking. So we had that question we asked right here, which was who are source allies black belts this year. Now, if I go to our query embeddings, you can see that we go find anything. We do a similarity search with score off of our vector store, and we pass it in a query. So in this case, let's go ahead and give it that exact same query. This is not going to answer for us, but it will give us what things are going to be passed in as a context for us. All right, and you can see here that we got a few results back. Score 0.22, score 0.208, score 0.208, things along those lines. There are a few of them. Score 0.169. So we know that those are the things that are going to be fed into our LLM before it actually answers our question for us. So let's go ahead and run our first script one more time and see what it tells us. All right, you can see all of our different current sources we have in our embeddings right now. Our question and then our answer now is Ben Joseph, Carla Leanyard, Gray Lovelace, and Kyle Hones were source allies black belts this year. I wasn't trying to brag, but there it is. The open model says so. So that is, oh, and it tells us exactly where the source that information came from was. So now that we kind of have a working example of what this looks like, let's go ahead and wrap it into our UI so you can dynamically add sources pretty easily without having to change a script. Now we have one more here called app.py. This is extremely simple. Once you kind of know the Streamlit library, it has a couple of funky things, especially around handling session state. If you're used to working in something like React, it's not super far off from that. But what you can see here is a few different chunks. We're going to set our page title. We're going to initialize some state. We have a sidebar, so we're going to go ahead and write out to that sidebar. One of the things that we care about here is get all of our current vector sources. So all of those things we printed out down here in the terminal, we expect to show up as already indexed sources of data on the left-hand side of our sidebar there. We need a way to delete all of the current data that we have so we no longer have that context and don't care about it. And then we have a way to load new sources of data. And then we also have a way to actually ask our questions and display the chat history as question and answer format. So let's go ahead and try to run that. And this is going to be pretty simple. It is just going to be poetry, run, Streamlit, run, and then source app.py. This should automatically launch for me. Excellent, and we can see everything here. You see all of these loaded data sources already. So let's go ahead and add another one just to see what that looks like. So I know we have an ML page for machine learning, so let's load that. All right, our info was loaded. You can see it pop up in our already loaded data sources, which is great. And then we can continue to ask any questions that we want. And this doesn't just work for Source Allies. You can point this at any website you want. But with, you know, where is Source Allies located? And this should be able to tell us the exact address that we want. Perfect. Urbandale, Iowa. It sometimes gets confused when you have so few sources right now. Actually, if we just had the one for the normal website, it would tell us the exact location, but it's trying to give us a little bit more general information since it has so many sources right now. So yeah, that is how you would use Retrieval Augmented Generation to interface with generative AI and be able to basically chat with your documents or chat with website content. Any way that you can kind of structure data to load it in and then generate embeddings from it, that's going to be how you can really feed that in as context anytime you ask a question. And then we're doing this with OpenAI APIs right now, which means that data is kind of like public to them. However, if you had private information that you needed, let's say that you were in an enterprise or something like that, you could very easily switch these over to point to more private models you maybe have hosted on Azure or AWS or something along those lines. And then all of that data would still remain private, but be able to follow this exact same pattern and be able to scale those data sources up really, really easily. Again, this has been Gray Lovelace with Technically Speaking with Source Allies. If there's a topic you want to see covered, please comment it down below. And if you want to know more about Source Allies as a whole, check out our description or our profile. Thank you for watching. It's been great, and we'll see you next time.